It's okay? Alright. This is for Sophia. I'm hoping that I can give this to her. At the end of this session, I'll pass this on as an email. Now, what I'd really like us to do today is actually finish up this particular chapter, chapter 3. As a note, looking back from the very beginning of chapter 3, we had, if we're going to do a bit of revision, we've done integration of what?
Logarithms.
That's the very beginning. Well, at the start of chapter 3, what type of distribution were we looking at in the end? Uniform and non-uniform
Distribution.
continuous random variables.
Yeah.
Yeah. And that's where it necessitated for us to learn how to do integration of functions, because integration is finding the area under the function.
Yeah.
And the area under the function is the
Probability.
good girl. It is the probability. Now we've said that a PDF, a probability distribution function, should be always equal to 1. Okay, now, having said that, now we're moving now to area in statistics, where we looked at expected value, variance, and standard deviation. So, our objective today is to get to a point where we're going to finish cumulative CDF, or cumulative density function. Okay, well, I'm just going to walk us through it. Now, this part of the whiteboard is what we've done. Okay, first up, expected value, or the mean of a probability density function. We know that, which is between the negative infinity to positive infinity, and it's x times the function, and you do an integration of that. We did that yesterday. We also did the variation, the variance x, and then with this particular formula, and then what we did then is, which actually, no, what we actually did not do in the end was doing a square root of that particular value, and the square root of that particular value of the variance is the
Standard
standard
deviation.
deviation. The only reason we didn't do that is because I thought that's just,
Squaring.
yeah, it's just squaring square root. No new skill, just trying to add more steps. Okay, be aware here that that symbol means,
Mean.
which is the
Expected value.
expected value. Thank you. Speak up a bit, Ainsley, so you can be heard.
Expected value.
All right. Then I hinted about change of origin, change of scale. And then if I said if B is a change of origin and A is a change of scale, which is being multiplied, the origin and the scale will affect the expected value. However, it's only the scale that affects the standard deviation. And if I square the standard deviation, and which means I have to square the scale as well, I will get the variance. Okay? So be aware of that. I need you to understand that. So you can go from here to there, and from there.
So change of origin only affects the expected value. Okay.
The plus and minus, basically.
Okay.
Multiplication, division, plus multiplication and division will also affect it, by the way. Okay, is that?
Yeah, it makes sense.
It's only, but this one will not be affected by the plus and the minus. I think that's what I'm trying to say. Because it makes sense if you think about it, because variance is the distance between scores, which is also what standard, it's a spread. And a spread never actually depends on the change of origin. It's more of how far am I, or how close am I from one score to another, which can be affected by a multiplication factor or a divisible, divisive factor. Okay. Having said that, moving on. Now we're on the current topic of CDF. The word cumulative, Muko, you would have. Muko is holding the camera. The word cumulative is actually being used in discrete random variable.
Yeah.
So you have a table, you have frequency, and then you have relative frequencies. Do you remember those words?
Yeah.
And the relative frequency is the frequency of a score divided by the total. So you will notice, and then you also have the relative frequency converted to percentages. You will notice when you go from 0, as you move along the scores, it will go, if you arrange them, it will go up from 0 to?
Infinity?
No, well, 1 or 100.
Oh, yeah, that's right.
Okay, it will go from 0 to 100. In fact, if I graph that, it would look like this. Okay? And if you feel you need a bit more revision on that, I didn't want to actually get more into that because that is past lesson. Your textbook, page 79 of your textbook should be able to do that, okay? Now, let's go back to this. At the same token as we have done here, compared to that, there's also a cumulative density function for continuous random variable. Okay, how do we do that? It's easy. It's fairly easy. But first of all, let's look at the differences. A PDF, a probability density function, usually for this particular graph, without the red mark, would look like this. So from 1 to 6, you're looking at 0.2, which is the function, and everything else is 0, okay?
It's linear.
It is. And if I want to find the area of that, all I gotta do is do this, fx, yeah? From 1 to 6, okay? In this case, it will be 0.2, so it will be 0.2x. That be fair? All right, now, coming back to this. However, in a cumulative, as it goes from 0 to 100, or as you mentioned before, 0 to 1, it will be, we need to actually do that in this case. Now, look at the differences. A cumulative density function starts with that. A probability density function has fx. Okay? A probability density function has the functions, whilst a cumulative density function has the probability or areas. Let me get back to that. That is the most important part. A probability density function has the functions, whilst a cumulative density function has the areas of probability. Okay? Look at what happens here. It starts from, look at this graph here. Let me do this first. First of all, we need to find how to calculate the area of this particular function here. So it's 0.2. Now, if you notice, I went from 1 to k. Now, k could be anything within here. Okay? So, let's do this. So, coming back to this. Let me erase this first. So, okay. Now, that will be 0.2 dx. Yeah? And then it would be, what is the integration of 0.2?
0.2x.
0.2x from 1 to k. Yes? Which means the area from 1 to something there would be 0.2 k minus 0.2 times 1, which is 0.2 k take 1. Yes? Which means any value here, as I go up, I can calculate any particular area between k and 1. Yes? All right. So this equation here gives me the area. And watch how I write this as a cumulative density function now. Which means the cumulative density function for that particular graph will go like this. Starts at 0, like this. And 0 goes from anything less than 1, sorry.
Yes.
Why did I do that? 1, x less than 1. And watch what happens. From 1 to 6, it will be basically, it will go up from some value to a higher value of 6 times 1, 0.2 is what? Oh, sorry, 5 times 0.2 is what?
1.
Is it 1? Okay, it will be 1. So from 1 to 6, but we don't know. The only reason I'm putting that area function there is because we don't know what that k is. So anything, so in other words, it will grow up to 1. And then it will go like this. X greater than 6, it will still be equal to, definitely be 1.
Because it's the probability.
Yeah, and because it's cumulative, it goes from 0 to some value until it reaches the 100%, or 1. So you can see the progression here. Is that fair?
Yeah.
Okay. Now, if I want to ask you what are the two big differences, number one, the PDF, go on.
Function with a PDF and starts with a probability for CDF.
Yes, and this one's got a function, and the probability here is you're looking at the
Integration.
area integration.
Area.
Okay, are we clear with that?
Mm-hmm.
Okay, now, you can stop that now, and I'll see if that was, thank you. How many minutes?